And the recording's going. So, John, it's all yours.
All right. Can everybody hear me okay?
Yes.
Great. All right. And you should be seeing the technician license class slide, hopefully.
Yep.
Okay. All righty. So today's session is on question pool section, technician section 8, which is entitled Signals and Emissions. We're going to be covering a number of subtopics: the basic characteristics of FM and single sideband, bandwidth of the different modulation modes, choice of emission type, amateur satellite operation, operating activities, non-voice and digital communications. There's a number of acronyms and abbreviations throughout these questions. I have just uploaded into chat a PDF of these slides so that you can have this material and also these definitions, which I'm not going to go into detail on. They're available here. And I'll just move ahead. I'll try not to use them when I'm talking, at least not the first time I use it. So basic characteristics of frequency modulation and single sideband. There are various modes of operation for radio, CW or continuous wave, single sideband, AM, like your AM radio in your car, amplitude modulation. Single sideband is a type of amplitude modulation. It's a little bit different. We'll talk about it. Slow scan TV, SSTV, and faxing. It's a way of sending images. Amateur TV. PSK31 is a data mode of phase shift keying. I forget where the 31 came from, but well, it was the width, 31 hertz. That's right. RTTY is radio teletype. PACTOR are two modes of data transmission for HF. And AX25 packet is a data transmission primarily for UHF, VHF.
Recording in progress.
Oh, recording in progress again. Okay. So amplitude modulation. Is that a question? Buster? Hello? Somebody have a question? Guess not. Okay. Amplitude modulation. The illustration at the top is an unmodulated radio frequency carrier wave. It's just a plain noise, if you will. A carrier wave with amplitude modulation is below, and you can see how there's peaks and valleys, and that's as the amplitude of the sound wave of the wave is made to coincide with the whatever it is you're transmitting. The voice, as your voice changes, it modulates the signal by increasing and decreasing the amplitude of the wave. That's amplitude modulation. So you can see here in the illustration at the top, if you were looking at a spectrum analyzer view of what the wave looks like, an unmodulated RF carrier, you can see is fairly narrow. It's just that peak right there in the middle. It's not being modulated, it's just there. But when once you modulate and change the amplitude, you create the signal on the carrier, but you also create what are called sidebands. And that requires more bandwidth. As you can see, it's much wider than the carrier is. And the transmitter power is spread across this bandwidth. Okay, so this is amplitude modulation. The difference between AM and single sideband, you can see here that there's two sidebands. There's one on the, as you're looking at this, one on the left and one on the right. We call them an upper and lower, but in this, as you're looking at them here, they look like they're left and right. And then the center carrier. What happens in single sideband is they filter out one of the sidebands and the carrier and only transmit out one of the two sidebands. So this requires less energy, and it also takes up less bandwidth. So the only thing that's actually being transmitted over the air is the one sideband. Now, there is a little bit of distortion of the signal as a result of this, and single sideband has a different sound to it than, for example, FM does. It's the reason why your music carriers are radio stations are FM carriers, because you get a higher quality signal than you do with AM, and even less with single sideband. So FM, or frequency modulation, instead of the carrier's amplitude being changed to coincide with the voice or whatever it is you're transmitting, the frequency is modified, is modulated. So the bandwidth stays the same. It's the frequency that's changing. And you can see the upper illustration there. It's a very uniform. It's an unmodulated carrier. It's very uniform. The modulating signal, the one that's going to be applied to the radio signal, you can see is a sine wave there. And then you can see in the bottom illustration that the waves are closer together in one area and then wider apart, closer together, wider apart. That's because the frequency is being changed. It's being modulated. Okay, so that's sort of the basic background on AM single sideband and FM. So let's take a look at some of the questions you might see on the exam, or you will see on the exam, actually. So which of the following is a form of amplitude modulation? Well, we just talked about how a single sideband is created from an AM signal. So the answer is going to be single sideband is a form of amplitude modulation. What type of modulation is commonly used for VHF packet radio transmissions? There was a chart, original chart we looked at, that had all the different modes and whether they were data or voice. Well, FM or phase modulation, PM, are the ones that are used for packet radio, and packet is a data transmission mode. Okay. Which type of voice mode is often used for long distance weak signal contacts on the VHF and UHF bands? We didn't really get into this, but because you use up less power on single sideband, just sending one sideband, you're going to get greater distance for the same amount of power out, essentially. So the answer is single sideband. And single sideband is what's most commonly used in the HF bands, but it can also be used for longer distance simplex contacts on the VHF and UHF bands. What type of modulation is commonly used for VHF and UHF voice repeaters? So the repeaters that you use with your handheld, your HT, they are not going to be AM or single sideband. They are going to be FM. Okay. So let's take a look at, we talked a little bit about bandwidth. Let's take a little bit closer look at bandwidth and how that impacts your choice of emission types. So here's an illustration of the different bandwidth. You can see that it shows that CW is between 10 and 150 hertz. And on the illustration on the right, you can see that tiny peak there, that sharply peaked signal on the left. For phone or voice transmission, single sideband is 2 to 3 kilohertz. AM is going to be 4 to 6 kilohertz, because remember, AM has both sidebands, so it's going to be twice the bandwidth, right? FM is in the range of 10 to 15 kilohertz, so even wider. So FM requires greater bandwidth than AM or single sideband. In your digital modes, you look at PSK 31, you see it's way down at not kilohertz, but hertz, 31 hertz. Okay. And you can see that radio teletype, or RTTY, is also very, very small, 250 hertz. Slow scan TV, 3 kilohertz, equivalent to sideband. And fast scan TV, or ATV, is more like AM, 6, or actually quite a bit larger, 6 megahertz. And you can see those illustrations on the right. So FM, remember, takes up quite a bit more than the other modes. Amateur television signal, here's an example of what that looks like. With a 6 megahertz channel, it's much wider. This is not something that people are... I don't run into very many people that are interested in this, but if you are, some information about it. And there are some questions on the exam. Okay, conventions. UHF, VHF repeaters and packet radio use FM. Remember, I mentioned it's a higher quality signal. Frequencies below 10 megahertz, this is talking about HF. Frequencies below 10 megahertz use lower sideband, and frequencies above 10 megahertz use upper sideband. There's no really good reason why. It's just historically that's what people did. And so that's what you will find. Narrower modes require less power to travel long distances. That's why we talked about single sideband, providing that one question that single sideband for VHF, UHF would provide longer range than FM. Because it's the narrowest of the analog voice modes, single sideband is popular for long distance communications. Your HF voice communications that you will normally see is going to be single sideband. It uses less spectrum. It's got that narrower bandwidth, so it uses less spectrum, and you can get more bang for your buck, if you will. As I mentioned, though, there is some loss in quality with single sideband, but it is the mode of choice for long distance voice communication. Okay, so let's see some of the questions. Which of the following types of emissions has the narrowest bandwidth? Well, remember, first thing we looked at was CW bandwidth was 10 to 150 hertz. So that's the smallest. So CW is your narrowest bandwidth among those modes. Which sideband is normally used for 10-meter HF, VHF, and UHF single sideband communications? So the question is 10 meters above or below 10 megahertz? Well, 10 meters is in the 50 megahertz range, so it's going to be above 10 meters, which means that it's going to be upper sideband. Okay. What is a characteristic of single sideband compared to FM? Well, they're actually not easier to tune. Single sideband signals are definitely susceptible to interference. Single sideband signals have narrower bandwidth. All these choices are correct. Well, all can't be right because we've just said 2 of them are wrong. So obviously it's by elimination, it is C. Single sidebands have narrower bandwidth. What is the approximate bandwidth of a typical single sideband voice signal? Now, on the slide we showed that, we gave a range, but basically it was around 3 kilohertz. Okay. What is the approximate bandwidth of a VHF repeater FM voice signal? Remember, it was quite a bit wider than a single sideband, and that range is 10 to 15 kilohertz. 10 to 15 kilohertz. Remember, this is in kilohertz. CW is in hertz, and PSK is 31 is in hertz. Your TV, your fast scan TV is in megahertz, much wider. What is the approximate, which gives away the next question, approximate bandwidth of AM fast scan TV transmissions? It's more than 10 megahertz, or it's about 6 megahertz, about 6 megahertz. What is the approximate bandwidth required to transmit a CW signal? Remember, CW is quite narrow bandwidth, very little. And that correct answer on that is 150 hertz. Okay, the 2.4 kilohertz would be about what you have for a voice single sideband. Which of the following is a disadvantage of FM compared with single sideband? Well, the voice quality is actually better. So it's not A, which means it's also not D. And the signals are not hard to tune. Actually, sideband is much harder to tune. So only one signal can be received at a time. It's a characteristic called FM capture. Once whatever the strongest signal is, that's the one that's going to be heard, the elimination of others. Whereas with single sideband, you can often you will hear overlapping signals, but you won't hear that with FM. Stronger one will just totally block out the weaker one. So only one signal can be received at a time. All right. Any questions before we move on to amateur satellite operation? Ready. Some definitions. Amateur satellites are low Earth orbit, LEOs, low Earth orbit. Most of them are what they call CubeSats. They're about a 1 foot cube, and they're just, as they say, they fly with as ballast with another large payload. I mean, it'd be too expensive to to send your amateur payload up on a space shuttle or something. So basically, they sort of get to ride along with real payloads. Satellites have beacons with telemetry data that shows the health of the satellite, so tells what it's doing. One of the problems with satellites is, of course, they're spinning up there in orbit, which means you get a characteristic called spin fade, which happens because the antenna, as it's rotating and as it's moving through space, it's changing, and which means that the signal is going to get stronger and weaker depending on how that antenna is pointing. Satellites generally repeat across bands, so usually they're going to be vertical up, or VHF up, UHF down. So you're not. It's not like a repeater where you have to have you have to do certain things to prevent it from interfering from the signals, the incoming signal and the outgoing signal from interfering, because they'd have to have some sort of frequency separation. Well, they'd get that by using different bands, VHF up and UHF down. Satellites may accept and repeat different modes, CW, sideband, FM, packet data. They're able to do all of that. If you use too much power when you're trying to contact a satellite, you're basically going to block out the other users. So you're generally using fairly low power on these. And you typically are going to set the power level by listening to the downlink. Should be about the same volume and power as level as the beacon is what you should be setting it for. Okay. Keplerian data. Keplerian elements are basically bits of data that tell a program where the satellite is in space and what it's doing. without getting into any detail, which frankly, I don't know much about them. But it's the data that the satellite will transmit that will permit you to track it and know where it's going to be at a point in time and how it's traversing. So that's transmitted by the satellites. Doppler shift. I think we're all, familiar with Doppler shift in sound. You know, when you hear the train coming towards you and the train whistle, and the pitch seems to be going up as it's coming towards you and down as it's going away from you. That's a Doppler shift. Same thing happens with RF waves, as shown in this illustration. Same thing happens. So the wavelength is essentially changing. So if the wavelength is changing, that means the frequency is changing, which makes it a little bit more complicated to be doing radio transmissions because the frequency is not constant. And software that's used to work with satellites takes that all into account. And here's a picture of Susan Helms, who's a ham, who's was a flight engineer on the International Space Station. I'm not sure exactly when. It looks like the photo was 2001. Anyhow. So let's take a look at some of the exam questions. What telemetry information is typically transmitted by satellite beacons? The signal strength of the received signal, we never mentioned that. Time of day, accurate to plus or minus 1/10 of a second, where that came from. The health and status of the satellite. Remember, that was the first thing we talked about, health and status of the satellite. So that's the correct answer. What is the impact of using excessive effective radiated power on a satellite uplink? Well, you're not going to command the satellite into an improper mode. They've got safeguards against any tampering with the satellite, obviously. But you're going to block access by other users. You're not going to overload their batteries, has nothing to do with their batteries, or reboot the satellite computer. You're basically going to block other people from using it. Which of the following are provided by satellite tracking programs? So we really didn't get into much of that. That illustration showed it a little bit. Maps showing the real-time position of the satellite track over the Earth. Obviously, that would be important if you're tracking a satellite. The time, azimuth, and elevation of the start, maximum altitude, and end of a pass. So basically, the time and direction you need to point your antennas to track that satellite, that would be important. So that's part of the software, and the apparent frequency of the satellite transmission, including the effects of Doppler. As I mentioned, software takes that all into account. The answer is all of these choices are correct. So your satellite tracking programs do all of that. What mode of transmission is commonly used by amateur radio satellites? Remember, we said they do various modes. They do sideband, FM, and CWR data, so all of the choices are correct. It's not just voice. It does not just FM voice. It does everything. What is a satellite beacon? As it implies, beacon is a transmission from the satellite. It's not the antenna. It is a transmission. And so it is the transmission from a satellite that contains the status information, the health and status of the satellite. That is what's called a satellite beacon. Okay, which of the following are inputs to a satellite tracking program? You might think that all of those sound like they're plausible, but the answer is simply the Keplerian elements that we mentioned, which is all the data that's needed for the tracking program that comes from the satellite. What is Doppler shift in reference to satellite communications? Well, it's not a change in the orbit, and it's not a mode. Remember, it's just like sound Doppler, except it's radio frequency. It's an observed change in signal frequency caused by the relative motion between the satellite and Earth station. And Earth station means you, person on the ground. That's Doppler shift. Oops. There we go. What is meant by the statement that a satellite is operating in UV mode? Remember we talked about how you have to have frequency separation for your uplinks and your downlinks. So in this case, it says it's in the uplink is in the 15-meter band and downlink is in the 10-meter band. Well, those are HF frequencies, and UV is UHF and VHF. So it means the satellite uplink is in the UHF, which is the first letter, 70 centimeter band, and the downlink is in the 2-meter or VHF band. This has nothing to do with ultraviolet. And usually variable is an interesting red herring. What causes spin fading of satellite signals? Okay, we've talked about that, how the antenna on the satellite is moving in different dimensions. It's the satellite itself is turning, it's rotating around the Earth. So it's the rotation of the satellite and its antennas. That's what causes the signal to fade in and out. What is a LEO satellite? That was one of the acronyms early on there. We talked about LEO is short for low Earth orbit. Low Earth orbit. Who may receive telemetry from a space station? Anyone. If you're anyone can receive. Now, transmitting to a space station is a different question, but anyone can receive that signal. Okay, all the stuff about licensed amateur would only apply if you were transmitting. Which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? Remember we had a slide, we talked briefly about how the signal strength on the downlink should be about the same as the beacon. So if you're listening to the downlink, it should be about the same as the beacon. If not, then you should adjust your input to it. So your signal strength on the downlink should be about the same as the beacon. Okay. Questions before we move to the next subtopics? All right. Again, some definitions. Radio direction finding, or sometimes RDF, radio direction finding, requires a directional antenna and a signal strength meter and can be used to locate noise sources and jammers. So that's what's commonly called fox hunting, radio direction finding. Contesting is popular and requires, it's basically a competition where you try to get as many contacts and many stations as you can in a certain period of time. And sometimes there'll be certain criteria as to, depending on the contest, as to which stations count for how many points or whatever. But it's a type of competition that's very popular, and it's a good way to get on the air and practice your skills. Maidenhead grids. This is a grid system that's used in amateur radio, covered for the whole world, not just the US. It's a worldwide grid system. It consists of typically 4 to 6 characters, depending on how small an area you want to narrow down to. But you can see an illustration here of the first 2 characters will be letters, and that gets you into a big square around the world. You can see it goes C to the left, D to the right, so it's going left to right or west to east alphabetically, and then from the pole south to the north. The alphabet goes down the alphabet. So, for instance, CO would be north of CN. And then within each of those squares, you've got basically 100 subsquares. So CN87, if you were to look here, you can see on the, pull my hand. So CN, if you were going to the 87 square, that would put it right here. And you could see that would generally be in the Seattle, Washington area. Where am I? Whereas if you drop down here to CN85, that will be down in the Portland, Oregon area. And then these are broken down usually with two more digits, lowercase letters that break it, each of those numeric squares down into subsquares. But the 2-letter and 2-number defines a 1 degree latitude, 2 degree longitude. So it's a pretty big area, Echolink and IRLP. These are systems that allow you to link repeaters over the internet. Echolink allows, you have to have a amateur radio license to use the software. You can communicate over the internet using VoIP, voice over internet protocol technology. You can transmit through a repeater using a laptop that's connected to the internet, or you can do it with a radio through a repeater that's Echolink capable. Not all repeaters have Echolink or IRLP. IRLP works in a similar way. It links repeaters together around the world. You use the DTMF, what's it DTMF stand for? Dual tone multi-function or something like that. It's the keypad tones like you have used to have on your touch tone phones, or you have on your HT now. It uses those tones to activate various repeaters. So you could sit with your handheld wherever you are, punch in the right tones, connect to a repeater in Japan or Australia or someplace, and literally with an HT, you could be talking anywhere in the world. Similarly with Echolink, using their software. You don't need any special software for IRLP. Both use DTMF tones, touch tones to link. IRLP does only link repeaters, whereas Echolink you can connect with your computer or a phone even. Echolink, yeah, again, you have to be registered and a licensed ham in order to use Echolink or IRLP, either one. Okay, so which of the following methods is used to locate sources of noise, interference, or jamming? Well, if you want to find where something is, you're going to be doing direction finding, right? So you're going to use radio direction finding. Can be used to locate sources of noise or interference. Can also be done, you can plant fox hunts, or where you put out a little transmitter somewhere and people try to find it using directional antennas. Which of these items would be useful for a hidden transmitter hunt? Just what I'm talking about, a fox hunt. What would be the most useful thing? Well, that would be a directional antenna. What operating activity involves contacting as many stations as possible during a specified period? That was the contesting I was talking about. The answer is contesting. You can just think of it, it's a contest, it's a competition. Which of the following is good procedure when contacting another station in a radio contest? Sign only the last 2 letters of your call if there are many other stations calling. Well, the last 2 letters, that's not proper identification of yourself, and that's not necessarily going to help anything. Contacting the station twice to be sure that you're in his log. Well, he doesn't want to record you down twice. He's just wasting his time, or her time. Send only the minimum information needed for proper identification in the contact exchange. That's the answer. And if you listen to a contest, you'll see that it's very fast paced usually. And it's just, there's certain key pieces of information that are provided. Usually it's like a signal report. It's a standard format, a call sign, maybe your state or your ARRL section or something, and it's boom, boom, boom. Minimum information, quickly transmitted. That's the answer in contests. What is a grid locator? That's the Maidenhead grid I was talking about. It is a letter number designator assigned to a geographic location. It doesn't have anything to do with elevation, and it's not an instrument. It's those squares on the map. Okay. How is over-the-air access to IRLP nodes accomplished? You do not need a password of any kind. Remember, we said it was the keypad on your HT, the touch tones. That's the DTMF signals. That's how you connect to IRLP nodes. What is Voice over Internet Protocol? Simply a method of delivering voice communications over the internet. That's what many of us have for our landline phones, and you don't necessarily realize it if you have it with somebody like Comcast or something. It's actually a VoIP phone, usually. What is the Internet Radio Linking Project? Okay. It is a technique to connect amateur radio systems such as repeaters via the internet using VoIP, Voice over Internet Protocol. Which of the following protocols enable an amateur station to transmit through a repeater without using a radio to initiate the transmission? Remember, we talked about IRLP and Echolink. Echolink's the one that requires the computer. Echolink. Doesn't require, but it can be done with a computer. What is required before using the Echolink system? Complete the required Echolink training. No, there is no training. Don't have to purchase a license, but you do have to register your call sign and provide proof of your license. Again, only licensed hams can do this. What is an amateur radio station that connects other amateur stations to the internet? And I guess I didn't mention this. The answer is it's a gateway. A gateway is what they call it. We know what a repeater is already. It's not a repeater. A digipeater is a digital repeater. And a beacon is something that transmits a signal that you can receive. So the only one left is a gateway. Okay, questions at this point? All right, either everybody's asleep or it's clear as mud. Okay, so let's talk about non-voice and digital communications. Some of the modes that are available for these. APRS, short for Automatic Packet Reporting System. It provides real-time location mapping. You can send some short messages via APRS, weather information, things like that. The radio has to be one that's capable of doing APRS. Some have internally built-in equivalent of a TNC that you can, or a type of TNC that can provide the digital signals necessary, or you may need a separate unit to do that. PSK31, we mentioned before, it's phase shift keying with a very narrow bandwidth. It's a data mode. It's very efficient. It's essentially texting, like texting or chatting with the keyboard to keyboard over amateur radio. PSK 31. Analog television. There are a number of different standards in the U.S. We use what's called the National Television Systems Committee, NTSC standard. Some other stations use other ones. That map shows who uses different ones. There's European standards and American standards, and WSJT. That is a package of software, weak signal, made by Joe Taylor. That's why it's WSJT. Joe Taylor is a Nobel physicist at Princeton. And it has a number of different modes that are available with this software, which is free. You can download to your computer and you can do different things. One of the really popular ones is called FT8. FT8, see there, it's towards the bottom. It's an HF weak signal, and it's a way of making contacts literally all over the world with not a very sophisticated HF station, because it pulls the weak signals out through digital signal processing and allows you to pick up things that you would not normally be able to. So it's a very popular program. In fact, I heard somewhere where that's probably the most popular mode right now, at least in HF. DMR, digital mobile radio. I'm just going to briefly touch on this. It's certainly a growing in popularity system. It's an open standard digital. It is not your normal radios, your FM, your AM. Those are your HTs. Those are analog signals. These are digital signals, where basically your voice is broken down into ones and zeros and transmitted and then reassembled by a digital to analog converter at the other end. The thing about DMR radio is it uses what's called TDMA, or time division multiple access. It creates two channels on a single frequency that's 12.5 kilohertz wide. So it's got two different channels. So basically you can have two conversations going on at the same time, because each one of them is transmitting on and off. I think it's like every 30 milliseconds or something, alternating. So it's basically chopping your signal up into little bits, and only half of them go out over time, but that's more than enough for the signal to be readable. So basically you can get two conversations on the same frequency at the same time with DMR radio. That's kind of what is interesting about it for our purposes here. Let's see. Packet is data sent over the radio with a modem that's called a terminal node controller, or a TNC. I'll often hear people talking about TNCs. These can either be hardware-based or software-based terminal node controllers. If there's a sound card and PC with a sound card, you can have a software TNC and not have to buy a separate piece of hardware. The data is packetized, which is why it's called packet radio, and it has an error checking system in it. The header is going to contain the routing information and the packet number, and missing or bad packets will automatically be identified, and there'll be an electronic requesting back for repeats until it gets it correct, which is called ARQ, or automatic repeat query. So it's a way of sending email, for example, over radio. Packet radio is generally about 1200 baud. There are 9600 baud systems for packet. They're rare. Where I live, there aren't any that I'm aware of. If you want to think about what does that mean, 1200 baud, for us old timers, we can think about the old dial-up modem. Well, that's what you're talking about speed-wise. Talk about broadband HamNet. It's a high-speed multimedia use of modified Wi-Fi devices to create a mesh network, a network that links radios together. In the Puget Sound area, we have one called HamWAN. Covers it's 5 point something gigahertz ham band frequencies that it operates on for high-speed data. Electronic keyers used for CW. It converts your paddle key to the appropriate length. Modern radios usually include keyers. Okay, so that's an example of a electronic keyer for CW. All right, so exam questions. Which of the following is a digital communications mode? Okay. We mentioned packet radio. JT65 is one of the WSJT modes. So those would both be correct. So means that IEEE 802.11 must also be a digital communications mode, meaning all these choices are correct. What is a talk group on a DMR repeater? Okay, need a little explanation. We mentioned that you can have multiple conversations going on at once on DMR. You have two going on the same frequency at the same time. But another advantage of DMR is that you can have what are called talk groups, which is basically a way of selectively listening to a particular frequency on a particular time slot, so that you have a group of operators that are going to be listening on the same channel without hearing everybody else. It's a way to eliminate. So the answer is B. It's a way for groups of users to share a channel at different times without hearing the other users on the channel. So what kind of data can be transmitted by APRS? Well, we mentioned all three of these with that slide. So all of these choices are correct. We think generally of APRS as being position data, but it also can include text messages, weather data. So all these choices are correct. What type of transmission is indicated by the term NTSC? If you remember, that was a protocol used in the US and some other countries for television, color TV, analog fast scan color TV signal. Which of the following is an application of APRS? Providing real-time tactical digital communications in conjunction with a map showing the locations of stations. Showing automatically the number of packets transmitted via PACTOR. Well, that's a totally different system. Providing voice over internet connection between repeaters. That was the Echolink and IRLP we talked about. Providing information on the number of stations signed into a repeater. I'm not sure what that's supposed to be. The answer is A. Providing real-time tactical digital slide had a nice pretty map with locations of different APRS radios that we're transmitting. What does the abbreviation PSK mean? Talked about that at sort of the beginning here. It is phase shift keying. PSK 31 was the mode we talked about, which is phase shift keying that's 31 hertz wide. Which of the following describes DMR? DMR, remember, was digital mobile radio. It's a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel, or an automatic position tracking mode, that's APRS, automatic computer logging technique for hands-off logging while operating a vehicle. I don't know what that is. Digital technique for transmitting on 2 repeaters simultaneously. No, that would be linked repeaters perhaps, but it's the first one. It is a technique for time multiplexing 2 digital voice signals on a single repeater channel. Remember, DNR lets you have 2 conversations going on at the same time on the same frequency through time multiplexing. Which of the following is included in packet radio transmissions? A checksum that permits error detection, a header that contains the call sign of the station to which the information is being sent, an automatic repeat request in case of error. Well, the checksum goes with the automatic repeat. That's how you can determine the error and then do the repeat request. And there is a header with the call sign information. So all of these choices are correct. It is all of the above. What is CW? Continuous wave, Morse code. It's another name for Morse code transmissions, CW. Which of the following activities is supported by digital mode software in the WSJTX software suite? Now remember that suite had a number of different things. Earth, Moon, Earth was one of them. Weak signal propagation beacons was another one. Meteor scatter. It is all of the above. FT8 was another one that they didn't list here. That's the one that's very popular. What is an ARQ transmission system? Remember we said that ARQ was a repeat query, an automatic repeat query. So it is an error correction method in which the receiving station detects errors and sends a request for retransmission. ARQ is automatic repeat query. Which of the following best describes an amateur radio mesh network? I mentioned that briefly. It was talked about networking radios on amateur figure using commercial Wi-Fi equipment with modified firmware. You'll hear that term a lot these days about mesh networks with amateur radio. FT8, mentioned that that's a weak signal popular digital mode. So it is not a voice mode, and it is a digital mode. And I mentioned that it was operates with very low signal to noise ratio. It can get very, very weak signals and pull them out. So it's low signal to noise operation, digital mode. All right. Any questions? That's the end of the question pool. Is anybody awake? Well, if there are no questions, I'm going to go ahead and stop sharing. Oh, wait a minute. Do I need to do that? Maybe. I think yep, I think I'm going to have to do that to bring up the other presentation.
That's all they got to see is.
I have a question about one of the